Yes. So we were here, Gauss law. These were done in class. Have we done this question in our class?
Yes, sir. Yes, sir.
A point charge Q is placed on the line AH and just outside the cube of a distance at a distance r. What is the total flux of electric field through the surface ABCD? We have done the similar question. In that case, the charge was along the line of along the line of body diagonal. But here it is along the line of a phase diagonal. Yes. And suppose we are placing a charge at this point. Okay, I am trying to see this charge from the front face. So this is the line of the body diagonal. Sorry, a phase diagonal. This is the line of phase diagonal, and our charge is placed here. Now my first question, what is the total flux through the cube due to this charge?
Zero.
Zero, right? Now I have to find the electric flux through the surface ABCD. That means this surface it is talking about. This surface it is talking about ABCD. Now can you see that for this charge Q, this surface ABCD and this upper surface, they are similar. For this charge Q, this front face and this upper face, they are similar, symmetrical, right? As you can see that if I draw these two surfaces like this, the charge is somewhere here. Can you understand what I have drawn here? This charge Q is here, or it can be in front face here. So with respect to this charge, can I say these two surfaces are symmetrical, or is there any biasness on the two surfaces? Symmetrical. Whatever may be the flux on the top surface, that is the also flux through the surface ABCD. Can anyone tell me what is the flux through this front face?
Zero.
Why? Because you can see that the field lines are parallel to this front face. Good. That we can understand. Now, all of these three faces, I can say that if this flux is phi, this flux is also phi. So this is phi prime, this is phi prime, this is 0. So with all these three faces, I can say that the total flux is 2 phi prime. Right? Can you tell me what is the flux through the other three faces? That we have studied last class, that if the charge was placed at one corner of the cube, then 1/8 of the portion will be inside. So the flux through the three faces that I am talking about will be Q by 8 epsilon naught, and in that case these three faces, this top face, this front face, and this ABCD face will carry zero flux. But in this case, as the charge is slightly away from the corner, I can also say that the opposite faces will carry the same flux Q by 8 epsilon naught. So can I say that plus Q by 8 epsilon naught will become 0. So what is phi prime in this case? Minus Q divided by 16 epsilon naught. That should be the answer of this question. It is. So now move to the next question. I think we have done this in class.
Yes, sir. Yes, sir.
All right.
Yes, sir.
Have you done this question?
Yes. Yes, sir.
A charge distribution generates a radial electric field E equal to A by R square e power minus R by B R cap, where A, B are constant. Find the total charge. It is given that electric field is equal to something. Here it is say it is E naught into R cap. Right? Electric field is E naught. What is E naught here? E naught is equal to A by R square into e power minus R by B. Right? Now it is asking that what is the total charge in the space. If I ask you to find what is the charge inside the radius R, what I will do, I will integrate E dot ds through this spherical surface of radius R. Yes or no? And I will say that is q inside by epsilon naught. Now you can see, now answer this question, that every point on this surface, is the magnitude of electric field constant or not? Every point on the surface, is the magnitude of the electric field constant or not?
Yes, sir.
Yes, because you can put the value of R here. R is a constant at every point on the surface. Yes or no? At every point on the surface, is R a constant or not? Constant. So mod E is constant, you can take it outside. Cos theta, can you tell me what is cos theta at every point on the surface?
1.
1. Cos theta means the angle between electric field vector and the ds vector. This is electric field vector and this is also ds vector, right? So as cos theta is 1, so inside the integration what only is left out? ds. And what is integration of ds, can you tell me? For this spherical surface, what is integration of ds?
4 pi r square. 4 pi r square.
So is this integration is only e into 4 pi r square? Yes or no? So if you put the value of E as A by R square into e power minus R by B multiplied by 4 pi R square, then R square will get cancelled out. And now, if I ask you what is the total flux in the space, then can you tell me what should be the value of R in that surface? Infinity. So if you put R tends to infinity, what is the value of this integration?
0.
0. So that is why I have said that the q inside must be 0 for this question. Okay, so let's move to the next question. We have solved this one in class.
Yes, sir. Yes, sir.
We have solved this one in class.
Yes, sir. Yes, sir.
Have you done this one?
Yes, sir. Yes, sir.
What is the answer of this question?
Wait.
Lambda by 8 epsilon naught. Yes, it is lambda by 8 epsilon naught. Let me again briefly discuss this solution. Suppose it is the cube. It is the cube. And the cube has an infinite line where along one of its sides. So let us assume that this is the side where we have an infinite long charged wire, right, with lambda coulomb per meter. Now let us name different corners of the cube. Say it is A, B, C, D, E, F, G, H. Now can anyone tell me what is the flux through this cube due to this charge rod? Total flux through the cube.
Lambda A by 4 epsilon naught. Lambda A by 4 epsilon naught.
Yes, that we have done in last class also. Lambda A by 4 epsilon naught, because 1/4 of the rod between A to B is inside the cube. Okay. Now, can you tell me what is the flux at the surface ABHG?
0.
What is the flux through the surface ABHG?
0, 0.
Because this charge rod will produce a cylindrical electric field. Can you understand? This charge rod will produce a cylindrical electric field. Do you understand what type of electric field I am drawing here? Okay. So can you see that through this surface ABHG, the electric fields will be parallel to the surface? Okay. Can you tell me what is the electric flux through ABCD?
0.
Because it is also parallel ABCD. Can you tell me what is electric flux through this BCFH?
0.
BCFH is also 0. And what is electric
And
flux
AD.
through ADEG?
0.
ADEG is also
0.
good. So I hope that you can now visualize things, right? From your answer, I can understand that you can now visualize things, and it is very important in Gauss law. Now, if all these four faces are carrying zero flux, what are the remaining two faces? Can you see this? The remaining two faces, C, D, E, F,
Symmetrical.
and yes, and G, E, F, H, these are symmetrical.
Yes, sir.
So can I say this 2F, 2 phi is equal to total flux actually, lambda A by 4 epsilon naught? So each of the faces will carry lambda A by 8 epsilon naught. That should be your answer.
Yes.
Okay. Now, to solve this question, let us first try to look at the top view of the plane. It is infinite long in this side. Can you see from top view it is the plate? Suppose that the flux through this plate is phi, right? And the charge is placed at some point above this y-axis, along this y-axis. Okay, let us try to find out the coordinates. Its x and z coordinates are 1 and 1. This point, its point, x and z coordinates are 1 and 1. So this angle is 45 degree, right? Do you understand that I can find this type of similar plates in the surface like this? And all of these plates will carry the same flux phi, as these four plates are symmetrical from the charge q. Yes or no?
Yes.
Everyone? Sure?
Yes.
Yes.
Yes, sir.
These four plates are symmetrical from the charge q. But look, if I have to bound this charge q through the similar type of plates, then this part is still unbounded. This part, this triangle and this triangle. Yes or no? These
Yes,
two triangles are still unbounded. So let us assume the flux through this triangle is phi prime, and flux through this triangle is phi prime. Try to visualize, because this is also a complicated question, I think, because you have to visualize a lot of things. Okay. Now, can you see that if I say total flux is 4 phi plus 2 phi prime, but that flux is only along this xz plane, right? This xz plane. I could not bound this charge q through this entire plane. It is this side infinity and this side also infinity. Can anyone tell me how many numbers of this type of configuration, this entire configuration? Now let us assume this entire rectangle. This is a rectangular part, right? This is entire a rectangular part. Can you tell me how many numbers of such rectangles are needed to symmetrically bound this charge Q?
8.
Is it 8?
4.
4 numbers are needed, right?
4.
Because
So can you
yes,
spell again?
why this number is 4 you can understand. Suppose your charge is here. Can you see your charge from top view? You will find your charge here or not? From top view you will find your charge here. Yes or no? Can you understand?
Yes, sir.
Yes.
Yes,
Now this rectangular part is placed just below this charge Q. Yes or no?
Yes, sir.
So there should be another rectangular part just above this charge Q.
Yes, sir.
Yes. And
Yes,
now
sir.
you can see this side face of this charge Q. This side face I am talking about. This side face. This side face has to be bounded by also this type, similar type of rectangular part. Yes or no?
Yes, sir. Yes, sir.
And this front face has to be also covered by this similar type of rectangular part,
Yes, sir.
right? So how many similar type of rectangular parts are needed? Total 4 number of similar type rectangular parts are needed to completely bound this charge. Again, one can question that at infinity I have left it unbounded. Yes or no? At infinity you have left it unbounded. But does it matter? I have discussed in your last class that from infinity we will assume zero flux always for a finite charge distribution.
Yes, sir.
Now ask me if any question is there. That's all. This question, if you have understood this part, now there is only mathematical calculation. Have you understood this part?
Yes, sir.
Everyone?
Yes, sir.
Yes, sir.
Yes, could you visualize the entire thing that I have told you? That this type of rectangular parts are needed 4 times. So now, can I say, now my equation should be that 4 times 4 5 prime plus 2, 4 5 plus 2 5 prime. It is the total flux. What is the total flux? What
Q
is
by
total
epsilon.
flux? Q by epsilon naught. Is that equation correct or wrong?
Yes, sir. Correct, sir.
This equation is correct. Okay. Now again I have to find phi, but I do not know what is phi prime. Right. So let us first find what is phi prime.
Sir, 5
Yes.
prime, can we make a square out of the triangles
Yes,
and
yes,
then
yes.
find 5 prime?
That only we will do. Yes, good. That part you need to understand. That how do I find phi prime? Right. Let us again try to write down the equation. Equation was 16 phi plus 8 phi prime is equal to Q inside by epsilon naught. Now what is phi prime? That I will calculate from here. That suppose again I am seeing the same situation from top view. So this is my x, this is my z, right? And now I will only talk about the this triangular portions, right? Only triangular portions. You can see from the coordinates of triangular portion that this is one triangle, this is another triangle, right? Okay, if this is 45 degree, this is 45 degree, right? So this is actually a right angle triangle. This is also a right angle triangle. What is the side length? You can understand that this side is 1, right? This side is 1. If I can draw, let us join these two sides also, right? Now you can understand that this side was 1, this side was 1, this side is 1, this side is 1, this side is 1, it is also 1, it is also 1, it is also 1. Can you see that there is a square that I can form by similar type of triangles?
Yes, sir.
Right? So if this is phi prime, this is phi prime, You can also see that this is 5 prime and this is 5 prime.
So 24 5 prime there will be.
Yes. So if I
Into
have
square.
to bound this charge q, if I have to bound this charge q by symmetrical type of a square, first let us say, by symmetrical type of this square, how many squares do we need? Tell me.
Again, 6.
6.
How many squares do we need to bound this charge q symmetrically?
6.
6. Because 6 squares will form a cube. Right?
6.
So can I say that 6 multiplied by 4 5 prime is equal to q by
Is equal to
epsilon?
2 by epsilon.
Have you got this concept? Now
Yes, sir.
I have forgotten to find flux through this one, right? For a moment you forget this blue colored of plane, actually which we need to find the flux. But I have to find the flux first through this triangular portion. What I have said, that if you draw this square, you will find that 4 similar type of triangles are there in that square, and this type of 6 similar squares are needed to completely bound this charge q, so that the charge q will be at the center of that cube. So 6 into 4 5 prime, that will be the total flux q by epsilon naught. From there, can I find that 5 prime will be q by 24 epsilon naught?
Yes, sir.
Now I will just put the value here and I will find the value of 5. What you will get? 8 5 prime is q by 3 epsilon naught. What is your answer?
Q by 24 epsilon naught.
Yes, that 5 will also be q by 24 epsilon naught. That should be the answer of this question. I think you could have done this one.
Answer is 6.
Yes, the answer is 6. It says a non-conducting solid cylinder of infinite length having charge density rho and radius of cylinder 5r. If the flux passing through the surface ABCD is this one, then find the value. Actually, I have to find the flux passing through the surface ABCD. Okay, again, if you look from the top, if I look from the top, the situation will look like this. If you look from the top, then what you will get, I think you will find this one. If I look from the top, the center of the cylinder is coming towards you, right? The face AB, and okay, there is a circle of radius. Radius is 5r, right? Radius is 5r. Okay, so if I say that this is my radius 5r, right? This is the radius 5r, and AB is 8r. So this is 4r and this is 4r, 8r. This is again the radius. Can you visualize this top face of this ABCD surface?
Yes,
Everyone? Okay. From the top view, is this clear? From the top view, is this figure clear? OAB. From the top view, this AB is the plate. This length AB is 8r. As you can say that this is 8r. AB is 8r, and the diameter, the radius are 5r. Clear? From the top view.
Yes, sir.
Now, can you
Yes,
tell me that what type of electric fields this cylinder actually will produce? Will the cylinder produce radial electric field like this?
Yes, sir.
Radial electric field like this? The cylinder will produce a radial electric field like this. Now let us try to draw this in a 3D. Yes or no? Can you understand this part? that I have drawn in 3D. This is the plane from where I need to find the flux. Okay, now tell me one by one, what is the flux through OAB?
0.
Is it 0, the flux through OAB? Because the field
Yes, sir.
lines are parallel to this OAB? Yes or no? Everyone could understand this one. OAB part is 0. Can you tell me what is flux through OADP?
0.
OADP, because these field lines are radial, so this OADP is 0. Similarly, what will be flux through OBCP?
0.
OBCP. OBCP is also 0. Similarly, what is the flux through CPD?
0.
CPD is 0. So what is the left out part? It's only flux through ABCD or not?
Yes, sir.
So can I say that is only the Q inside this portion divided by epsilon naught?
Yes, sir.
Now can you find what is the volume of this prism type of thing that I have drawn? What is the volume of this? Let us first calculate the area of this upper triangle. What is area of this upper triangle? Half into 3r into 8r, can I say that?
Yes, sir.
Because this height is 3r. 5r, 4r, 3r. Can you understand this part?
Yes, sir.
Everyone, 5r, 4r, 3r. So this height is 3r. This side base is 8r. So this is 12r square is the area of this upper triangle. Can I multiply this 12r square with the height BC to find the volume?
Yes, sir.
So
Yes, sir.
volume is 12r square multiplied by r. So 12r cube is the volume. 12r cube is the volume. So what is charge inside? Can I say it is 12r cube into rho? 12r cube into rho divided by epsilon naught. That should be the answer of this question or not?
Yes, sir.
This question have you tried?
So Q by 48 epsilon naught. Yes, sir.
Q by
48.
Q by
48 epsilon naught.
Q by 48 epsilon naught. Yes, Q by 48 epsilon naught will be the answer. Right? Q by 48 epsilon naught. Okay. So this is a good question. I will not discuss the answer today only. I will discuss the answer tomorrow. These two questions I will solve it tomorrow. So today we will discuss with solid angle. This is also a part of Gauss law that we were discussing. What is solid angle? Before that, let us first try to understand what is a plane angle. Suppose this is a line and this is a point, right? And you are seeing that this line makes an angle, say pi by 4 or pi by 2. Let us assume this is pi by 2. This angle is pi by 2. How do you define this angle pi by 2? Right, you can measure this angle definitely, but how can you define this angle pi by 2? That we need to first understand before understanding solid angle. Right, it is very interesting thing. Try to understand this. Not only this line, if you have any other curved line, and if I ask you what is the angle made by this curved line at the center O, what should be your answer? Is it still pi by 2? Yes or no?
Yes, sir.
Now if I have a circular arc, and if I ask you what is the angle made by the circular arc at this point O, what should be your answer?
Pi by 2.
Pi by 2. Instead, if I say that the radius of the circular arc is 1 meter, Then what is the length of this circular arc?
Pi by 2.
Pi by 2. So can I define pi by 2 in this way? If we have any line, it may be curve one, it may be a straight path, it may be any line, right? It may be any line. If we have any line and we have to find the angle subtended by the line at some point O, what we will do first? We will join the end points of the line with the point O. Then we will find two straight lines. Then, taking the point O as a center, we will draw a circle of radius 1 meter. Then, the arc length of the circle that is trapped inside the two lines actually is the angle subtended by the original curve at the point. Have you understood the procedure?
Yes, sir.
Now in the similar way we are going to discuss solid angle. How do I define solid angle now? Just try to understand in a very similar way. If you have understood this part, solid angle is very simple to understand. Let us assume that there is a disk. This is a disk. You should visualize this. This is a disk. Now if someone asks you what is the angle subtended by the disk at the point O, then can you tell me what should be our first approach? The first thing that we will do is I will join all the points on the circumference on the disk with the point O. Can you see that? I am joining all the points on the circumference on the disk with the point O. Can you tell me what I will get like in this way?
Cone.
We will get a cone. We will get a cone like this. Right? We will get a cone like this. Now, how do I define solid angle? In case of plane angle, we have drawn a circle of radius 1 meter with the center at this point O. But in case of solid angle, what we will draw?
Sphere.
We will draw a sphere of radius what?
1 unit.
1 meter. We will draw a sphere of radius 1 meter and we will check what is the area enclosed by the cone of the sphere. That area is the solid angle subtended
স্পেয়ারের ভলিউম এনক্লোজ হবে না
না স্ফিয়ারের এরিয়া ওখানে একটা সার্কেলের লেন্থ ছিল এখানে একটা স্ফিয়ারের এরিয়া not volume. Can you visualize this part? It is very important to visualize that if we have a cylinder, if we have a disc like this, then we will first join all the points on the circumference of the disc with the given point O. Eventually we will get a cone. Then we will draw a sphere of unit radius taking the center at O and find the area that is trapped inside the cone of the sphere. That area will be the solid angle subtended by the cone at the point O. Right? This solid angle is given as steradian. Steradian. Right? Plane angle is given as radian. Solid angle is represented by steradian. Right? It looks like this. Sigma. Capital sigma is noted as solid angle. Right? Solid angle. Have you understood the concept of solid angle?
Yes.
Now can anyone tell me, if we have another disk like this, then what is the solid angle by the disk at this point O is the same, or it will be different? Same, right? Now the important part to understand is that you take any arbitrary surface, if you join the circumference points of the surface with the point O, and if you find the same cone, the solid angle will remain the same. Even if you have a surface like this, can you understand? This is a surface, a cap type of thing. When you join the boundary, the open boundary of the surface with the point O, you will find the same cone. So in that case, all of them are having the same solid angle. All of them are having the same solid angle at point O. Light source rakha ache. Let us assume that there is a light source placed at the center of the sphere, of a sphere. If I ask you that with this much portion of area, right, what is the light energy that is coming, then what you will do? You have to find the solid angle subtended at the center by this surface, right? And you can say that what is the total solid angle? Can you tell me what is the total solid angle subtended by this closed surface?
4 pi.
4 pi. How? Because if I have to find the total solid angle, then I have to find the total area of this of the sphere of radius 1 meter. And what is the total area of a sphere of radius 1 meter?
4 pi. 4 pi.
So total area is 4 pi. So you have to understand that total solid angle around any point is 4 pi.
স্যার ওটাকে মেজার করার কোনো ইনস্ট্রুমেন্ট আছে যেমনি আমাদের কম্পাস বা প্রোটেক্টর
না
দিয়ে প্লেন
এরকম
অ্যাঙ্গেল
কোনো ইনস্ট্রুমেন্ট নেই, সলিড অ্যাঙ্গেল মেজার করার কোনো ইনস্ট্রুমেন্ট নেই, বাট ফর্মুলা আছে, আমরা ফর্মুলা ইউজ করব। উই উইল চেক দ্য ফর্মুলা। ওকে, same thing that I have just said, it's written over here. So this slide will help you anytime to understand solid angle, right? As you can see. Now, the question is, can I find the solid angle if I have a cone? If I have a cone, suppose this one, if I could make a cone that has a semi-apex angle alpha, right? For any particular disk, at this point O, when I joined all the points on the circumference of the disk, I could find a cone. Suppose this is a cone that I could find, right? A cone which has a semi-apex angle of alpha. Now my question is, what is the solid angle for this distribution, for this disk at this point O? Again, what I will do, I will draw a sphere of unit radius, and I will find what is the area of that sphere that is trapped inside the cone, right? So how do I find the area of that sphere? I have to do only integration, right? So let us try to understand the integration part here. If you can visualize that the part of the sphere that I am talking about will look like this. Yes or no? Can you visualize this part
Yes,
of
sir.
the sphere that I am talking about? And this is the point O, right? This is the point O, right? Everywhere the radius is R. At every point the radius is R, right? That you need to understand. Okay. This center, let me place it here. The center is O. The radius is R. I have to find the total area if this angle is given as alpha. What I will do, let us take one thin circular ring. like this. Let us take one thin circular ring. One thin circular ring like this. The ring lies at angle theta in between angle d theta. Can you visualize this ring? Why I have taken ring? I have taken a ring on the surface so that this angle theta remains constant throughout this ring. Can you see the angle theta remains constant throughout the ring? It will produce another cone. If I join the circumference of the ring to the center O, it will produce a cone of semi-apex angle theta. Can anyone tell me what is the area of this small ring? What is area of ring?
2 pi d theta.
To find that, first find what is the radius of the ring. What is the radius of the ring?
Theta.
Huh?
Theta.
No. What is radius of the ring?
R d theta.
R. If the radius of this sphere is capital R, suppose it is capital R, then what is radius of this ring?
R sin theta.
R sin theta. And what is capital R? Actually 1.
1.
Right. So what is area of the ring? Can you see the area of the ring is 2 pi R into what?
2 theta. 2 pi R sin theta d theta.
2 pi R into simply,
Sin theta.
yes, 2
Sin
pi R
theta d
into capital R d theta. What is the width of this part? Can you see the width of this part is capital R d theta? Yes or no?
Yes, sir.
So now I will put the value. It is 2 pi into sin theta d theta. That is only the area of that ring because capital R is 1. Right? So this is ds. If I integrate this ds, can I find the total surface, and that surface area is nothing but the solid angle.
Yes.
What should be my integration limit?
0 to pi by 2.
0 to alpha. This angle is alpha. It is not a
Alpha.
hemisphere. Yes.
Sorry.
So can you tell me what is the integration?
Cos minus cos theta.
হ্যাঁ, লিমিট বসালে কত আসবে?
1 minus cos alpha. 1 minus cos alpha.
Yes. So this equation you need to remember always. Right? If there is a cone that subtends angle alpha, that subtends a semi-apex angle alpha at this point O, then actually it is making a solid angle of 2 pi into 1 minus cos alpha. Is that clear? Even if you do not remember or understand this, calculation doesn't matter. This calculation hardly matters. You should remember this equation. Right? This formula rather is very important. That solid angle is 2 pi into 1 minus cos alpha. In several places we are going to use this one. Let us try to solve this one. It says a charge q is kept at the center of a hollow cylinder of radius r as shown in figure. Find the flux coming out from out of the cylinder from the definition. So if I say that what are fluxes through this plane surface, let us first understand the flux through this plane surface. If a charge q is placed here, such that it subtends an angle alpha here. So what is the solid angle subtended by the charge q to the disk?
2 pi into 1 minus cos alpha.
The solid angle is 2 pi into 1 minus cos alpha. Now can anyone tell me What is the flux through this disk if the solid angle is this one? If the solid angle is this one, what is the total flux? The answer is very simple. If you have a complete sphere, then what was the total flux through the sphere?
4 pi q epsilon.
Yes. The total flux through this complete sphere is
Q by epsilon.
q by epsilon. Now,
For 4.
this complete sphere has a solid angle 4 pi. So can I say through the 4 pi solid angle, the flux is q by epsilon naught? So through this solid angle phi, what is the flux? Is it q by 4 pi epsilon naught into the solid angle? Is it clear? I have said that the flux through this solid, this curved, flat surface, the flux through this flat surface is this one. Have you got this part? क्या ये समझ में आया कि इस फ्लैट सरफेस से क्या कितना फ्लक्स जा रहा है? अगर इसका सॉलिड एंगल बन रहा है इतना और 4 पाई सॉलिड एंगल में फ्लक्स जाता है q बाई एप्सिलॉन नॉट, तो इतना सॉलिड एंगल में कितना फ्लक्स जाएगा? q बाई एप्सिलॉन डिवाइड बाई 4 पाई इनटू दिस 2 पाई 1 माइनस cos अल्फा. So the flux through this one is q by 2 into 1 minus cos alpha. Similar is the flux through this flat surface. So what is total flux through these two flat surfaces is this part. Now I will assume the flux through curved surface is phi curved. Can you tell me what is the total flux through this entire closed surface? अब ये सब q by epsilon. तो क्या इससे कर्व सरफेस का फ्लक्स निकाल सकते हैं हम लोग? कितना है ये बताओ? ये एप्सिलॉन
q by epsilon naught into 1 plus cos alpha.
q by epsilon naught 1 plus कहाँ से आएगा? q by epsilon naught into 1 minus cos alpha. यही आएगा ना बस.
আমাদের কার্ভটার জন্য বার করতে হবে.
হ্যাঁ, শুধু কার্ভটার জন্য বার, কারণ ফ্ল্যাট সারফেস তো অ্যাকচুয়ালি নেই, এটা একটা হলো সিলিন্ডার. কার্ভ সারফেস ধরে আমি ফ্লাক্স বার করেছি, মাইনাস করে দিলাম.
মানে সলিড অ্যাঙ্গেলের কনসেপ্টটা যে ইউজ করব যেখানে পুরো সিমেট্রিক হবে না.
করতে পারো. সলিড অ্যাঙ্গেল শুধু সেখানে ইউজ করতে পারবে যেখানে কোন ফর্মেশন হবে. রিমেম্বার, could we find the solid angle for a square? If a square is there and there is a charge q, and if I ask you what is the solid angle subtended by the square frame at the charge q, क्या इसको कैलकुलेट किया जा सकता है?
नहीं सर.
टफ है.
No,
कैलकुलेट कर तो सकते हैं बट टफ है, उसका कोई जरूरत है नहीं. राइट तो ऐसे सॉलिड एंगल कोई क्वेश्चन में नहीं पूछेंगे हम लोग कभी भी.
করতে তো পারি.
हाँ বলো.
করতে তো পারি.
করতে পারো. ইন্টিগ্রেশন অনেক রকম ইন্টিগ্রেশন করে সবই করা যাবে, ইন্টিগ্রেশন দিয়ে সবকিছুই করা যাবে. बट
सर सिमेट्रिक बॉडीज के लिए सॉलिड एंगल कॉन्सेप्ट यूज करना है.
सिमेट्रिक बॉडी के लिए मैंने नहीं कहा. ये सिमेट्रिक बॉडी है कि नहीं है उससे मतलब नहीं है. सॉलिड एंगल तभी यूज करो जब कोन फॉर्मेशन हो रहा है किसी चार्ज के ऊपर. अगर कोन फॉर्मेशन नहीं हो रहा है तो सॉलिड एंगल यूज करके कोई फायदा नहीं है, निकाल नहीं सकते हो, उसका फॉर्मूला पता नहीं है. ठीक है.
ঠিক আছে.
देखो ये क्वेश्चन है, इस क्वेश्चन को भी सॉलिड एंगल से ही हम लोग सॉल्व करेंगे. राइट so I will give this question as your homework. Okay, take this as your homework. So actually in today's class we have only covered one theory portion which is solid angle, but that is definitely a very important concept to understand, and we can solve different questions using solid angle in different chapters also, not only in electrostatics, in optics, in gravitation also we can use solid angles. So there are different questions, but I will suggest you to solve this question at home. And we have also kept these two questions, this one and this one. So these three questions you take it as your homework.